Our focus standard for this lesson continues to be from grade 8, Functions, Standard A, Define, Evaluate, and Compare Functions. Our topic for this video lesson is Mathematical Models, Graphing from Slope-Intercept Form. Our essential question is, what are the steps for using Slope-Intercept Form to create the graph view? And this is specific to linear equations because Slope-Intercept Form is specific to linear equations. So let's go ahead. Once you have your header set up along with today's date, your question column, and your note column, let's go ahead and begin. Today we're going to talk about the 3 steps to graphing from the slope-intercept form of the equation. So our first step is to plot the y-intercept, or the b value, from the equation. And then from that point, we're going to draw in the slope, the m value. So we're going to use the change in y and the change in x to do that and plot that point. One thing to keep in mind, and we've seen this a little bit, is that the m, or the slope value of the m, is a whole number. That whole number is going to be your change in y, and your change in x will be equal to 1. And then, so now we plotted the b value, so we have the y-intercept plotted, and then from there we're going to draw in the slope triangle using the change in y and the change in x, so that gives us our second point. And then for our third step, we're going to connect both points with a straight edge. We want to make sure that we extend the line when we connect those points all the way through the edges of the graph. We don't want to stop just from the y-intercept to our next point and just connect those 2 parts. We want to go all the way through to the edges of the graph so it can help us predict values and look at the behavior of that linear relationship. So those are the 3 steps. Let's go ahead and take a look at our first example. So here we're being asked to graph the equation y equals -1/4 x plus 1. So our steps tell us that the first thing we want to do is plot the y-intercept. So we have to be able to identify from this equation what our y-intercept is. Remember, in slope-intercept form, y equals mx plus b. b represents the y-intercept, and it is the part of the equation that stands all by itself. So this plus 1 is going to be our y-intercept. What is the ordered pair then? If our y-intercept is 1, where are we going to find that? Well, it might be helpful to just graph it first and then talk about that. So I just want to make a side note here. Although you can't see a scale here on my graphs, I didn't want to clutter it up for the sake of this video demonstration. So I just made a note that the x and y scale are 1. So every line is counting by 1. So this is 0, 1, 2, 3, 4, 5. So we want to graph our y-intercept of 1. Go ahead, pause the video. Where do you think that point is going to be? Alright, so I've gone ahead and I put it right here, where y is 1 on the y-axis, because the y-intercept is that point where it's going to hit on the y-axis, so that would be right there. So if you didn't already figure this out, what is the coordinate pair for this point? Well, because it's on the y-axis, we know that x is 0 on the y-axis, and the y value is 1. The ordered pair for our y-intercept is 0, 1, and that's where we plotted our point. So now the directions say to draw in the slope, the m value. So we have to remember that slope is the change in y over change in x. So our change in y goes first, and so from here, it says it's -1/4. I like to give this negative to the y. So I'm going to say that the change in y is -1, based on up here, because the slope or the m value are always the coefficient in front of the x. So -1, and the change in x is going to be 4. So from this point, Our slope is telling us to drop 1, that would be our change in y, and to run 4, and to plot another point. Go ahead and do that. So here's our second point, because we've dropped 1, and that was our change in y, and our change in x was plus 4. So our third step is to connect those 2 points with a straight edge. And remember, you want to extend all the way through your graph. Alright, so if I use my straight edge to connect through, then our line should look like this. And we can see that this would actually have one more point right here. We could fit this in, and it would still follow in line with the drop 1, run 4, drop 1, run 4. So if it helps to have a third point, you have to make sure your line is on the correct slope, then you may want to backtrack and do a little bit of that too. And you could have put a third point here. But there we have it. From this equation, y equals negative 1/4 x plus 1, we identified from our equation what the y-intercept was and plotted that point, and then used our slope, finding that in the equation first and identifying it as its change in y over change in x, and plotted our second point, and then connected those with a straight edge. Let's go ahead and try one more. So for our second and final equation, we're being asked to graph y equals 2x minus 3. So go ahead if you want. I'm happy to just have you pause the video right here, and if you want to see how far you can get and then resume the video when you're ready to compare your work with mine, that would be great. And then if you get stuck anywhere along the line, just go ahead and resume the video and let's check in. So go ahead and remember our steps above. We first want to identify the y-intercept, plot that point, and then we want to, I use the slope to plot our second point, and then connect our 2 points. So far, what I have is I've identified that from this equation, negative 3 is my b value, which is my y-intercept, and the coordinates for that would be 0, negative 3, and I plotted that here on my y-axis. And again, in this graph, I'm using a scale of 1 on both the x and y. And I've identified that my slope is 2/1. So there's a little side note up above in those steps that said, if your m value is just a whole number, that whole number is going to be your change in y. That's going to be the numerator. And your change in x is going to be 1. And the reason for that is we can still divide 2 divided by 1, and we get that value of 2. That's in its most simplified form. So we want to use this slope to plot our second point. So from this point, it tells us our change in y is going to be plus 2. So we're going to go from negative 3, and we're going to go up 2, and our change in x is 1. So we're going to go over 1 and put a point. And it might help us to do that a couple times. To go up 2, over 1, put another point, up 2, over 1, put another point, and then that helps us make sure we keep that slope the same throughout the whole line that we're drawing. So go ahead and plot your points and connect your line. So our finished graph should look something like this. And again, the directions, the steps, they only have to have 2 points. And that's true, but sometimes I find that my ruler or my straight edge will slip a little bit as I'm drawing that. And so having an additional point or 2 can sometimes help to make sure that you keep that slope accurate all the way through the graph. And so here we have the graph in the equation, y equals 2x minus 3, negative 3 is our y-intercept. Our slope is positive 2, it goes up 2 over 1, up 2 over 1. So that concludes our video today, and please make sure that your notes are complete and you're ready to do more exploration with Slope-Intercept Form.